Hi guys, so in this video we're just going to be doing the introduction to vertical projectile. Right? So what is vertical projectile and what does it do? For those who don't know yet, it's under the physical science of which we all know that by now. Alright, so let's start. Vertical projectile. There are two terms that you need to understand in vertical projectile by now. The first one being free fall and projectile itself. So what are those terms and what are the definitions of those terms, right? So first one is projectile, like I said, and free fall, right? So both of these terms have two different meanings. So the first one, basically projectile, is defined as follows: it's an object which has been given an initial velocity and then it moves under the influence of gravity only, right? And the second one of which, free fall. Free fall itself is a motion during which the body only experiences one force, which is gravity. So those are the two terms and their definitions. I won't write them down, but you can just go back and listen at the video again. So these two terms are mainly important. So we're going to be debunking them and then getting into the more critical aspects and the graphs and stuff as the video goes on, right? So as I said, projectile itself, it involves initial velocity. Right? Free fall itself, a motion moves. It's a motion in which a body moves under gravity, right? Under the influence of gravity, right? So those are two different things. So if they tell you that this object itself it's thrown off a balcony or wherever, they mean that it is projected. For instance, I'm going to give two examples for projectile and free fall. Projectile, say for instance there's a person here standing on a top of a roof of a building, a tall building, and this person has a ball. Now this ball, the ball itself, the person then decides to project the ball, right? He projects it at a certain speed of 3 meters per second. So I've already given it out. It is projected. The person threw the ball with an initial velocity of 3 meters per second, meaning that this ball itself has been projected. It has been given a velocity. In simple terms, you can just say projectile, the object is given what? Velocity. In simple terms, you can just say that the object is given what? Velocity. Now in free fall, we have a ball that is falling down. The ball itself is falling down to where? To the ground. Now, while it is falling down, it is experiencing a force. A force of what? A force of gravity, which is G. Now, as it is falling down, there's a certain speed that it's moving with. But we don't say it's speed, we say it's an acceleration, which is the gravitational acceleration, of which is what? It's 9.8 meters per second. Right? So that's how you can debunk these two terms themselves, and you can understand them that way. The first one being projectile, an object will be given velocity. That's how you can say or think about it. Now, free fall, the object itself falls under the influence of gravity. Now, here's one thing that many students don't understand. Vertical projectile does not end here. It is also included in some other parts of Newton's. Immediately when they say, for example, this one I'm just going to do it in the end. When they say that a cable snapped, the cable snapped, now the object will be falling down. Now we can say it is free fall, and then you're asked to find what the acceleration at which it falls at, right? Of which it will be what 9.8 meters per second. Happy? Hope everyone understands. Now, moving from what I have just said, now I want us to talk more about the formulas that we will be using, of which these formulas are called what? They're not formulas particularly, but they say they are equations of motions. Right? Right. So these equations of motions are the equations that you can use to find the motion of an object, to find its initial velocity or its final velocity or its change in y. By change in y, for those who are just beginning, we are talking about the distance in the y axis. Right? I'll write them down. So here we start. So the equations of motions, we have them as follows. We have the first one, which is the one that is most popular, which is the Vf. It's equals to the V initial plus the acceleration and change in t, right? And yes, this acceleration, for someone who's asking, it is 9.8 meters per second. You won't need to calculate it unless the situation changes. So this is the first one. Now we have the second one, which is Vf squared, which is equals to V squared initial plus 2a change in y, right? And now this is the second one. Now the third one we have as the change in y. Now the change in y, which is equals to the v change in t plus 1 over 2a change in t squared. This is the third one. Now the fourth one, which is the change in y, which is equals to v initial plus the vf over 2 change in t. Now this is the fourth one. Now, in the beginning of each and every textbook, for every student that's beginning, they will tell you about in the x and in the y. Now this is in the y. Why? Because we're saying change in y. Now if it was in the x, you just replace everywhere that you see with y with x. You just say change in x here, and here change in x, and here change in x. That's the big difference between those two things. Now, to define all of them, the Vf is the final velocity. Now the V initial, it's the initial velocity. This is the velocity that it starts with, the initial velocity. Now the A, which is the acceleration. Now here comes the tricky part. In this chapter itself, direction is important. It's the most important thing that you have to know and respect. Because the acceleration, if you're going downwards, we say it is positive 9.8 meters per second. Now, of which I will teach you obviously how it works, and if it's negative, it's in which scenario and what happens, so on. And we have the change in t, as by now most people know it's time. Now we have to know the units of all of them. I'll write them down after I'm done here. Then we have the change in y, of which this one is the displacement. The displacement, the amount of distance the object moves or it covers, right? Right. So let me try and, for those that want to understand these things, right? Now velocity, I'm gonna use a different marker. Let me just use yellow. Now velocity, it's meters per second, right? Acceleration is meters per second, and then displacement is meters, right? So this are the units. You have to also know and write those units because they're important. They may seem small now, but once you get to tertiary, you will see that they are important, right? So this is basically what you have to know for the introduction of the equations of motions. Now, we're not done. We're just beginning, right? All right. So now I want us to talk about the projectile path, which we're going to do that in the next page, this side. what is the projectile path? Basically, we're just talking about the distance that the object moves under, right? Or with. Alright, so imagine this scenario. Now we have a ball of which it is thrown from point A to point D. Now this ball it is thrown here and here. Now one thing I want us to know or to notice is point A is the beginning and point D is the end. Right? So if you look at this and you cut it up, by the point that the ball, by the time the ball gets here, it's at its Vmax. Now at Vmax, what happens? The velocity is 0 at Vf, at the maximum velocity, because the ball itself reaches a point of which it stops. Right? So that's point number 1 from this scenario. Now the second point is this. The displacement that the ball moves is half the displacement on the side, right? From point 1 to point 3, right? So from this side to this side, the ball moved the same distance, right? Okay. So those are the things I need you to know. Vmax, Vf is equals to 0, and same height, as long as it's on the same ground, the change in y is the same, and the v initial, it will depend. That one depends, but sometimes it may be projected or something. But in most cases, it can't be dropped, right? Good. So yeah, these are the simple type of a projectile that I can think of right now. But then the complex ones, we're going to be doing them soon, right? Okay. So now I want you to think about this. You're still under the projectile. Now we're going to be doing the graphs using the same scenario that we created, right? So now think of a person here. Here's the person. Now this person is throwing the ball up, and the ball comes down. Now this is the ground. I want us to talk about something. Good. So now if you're required to draw the vertical projectile graph of this ball, basically, or to describe its motion, you have to take what? Up will be what? Will be positive, and down will be what? Will be negative. Right? Two different things of which you have to understand. Right? And your graph will also be slightly different depending on how you draw it. For instance, if your up is positive, your graph will be like this. You're changing y graph. If up is positive, describing the same motion from this point, let me use a different color. From this point, the motion will be like this. Why? Because you're basically just drawing this thing. That's the distance or the path that this ball moved with. And this is changing t. Now for the velocity graph, I'm so sorry for the way it is, but then it's fine. For the velocity graph, it will be like this. Now someone may ask, say, why are you drawing it like this? Why is it like a parabola or something? Why is it a straight line? Now remember, there's a velocity, as it's going up, it's decreasing, right? So now if I was to draw it in a parabola, it would look very silly, right? Okay. So now in this case, as the ball goes up, the velocity goes down. So that's why it has a negative gradient here. But immediately as it reaches the 0, as I said, the Vf, if this is the V initial, the Vf at this point will be what? Will be 0, as I said. It will go down. As it goes down, it will go what? It will increase its speed. That's why here on this side, it's going to be higher. Now the difference between -1 and -10 is -1 and -10. Now this one is bigger than this one. Right? Yeah. Right. So this is the what? This is the change in y versus change in t, change in v versus change in t, and now for this one here we are going to be right. This is the change in t, then this is the change in v. So this is the graph here, and this is the graph here, right? Good. So now for the what happens to the acceleration, right? So those who are asking, acceleration versus the time. Here's what happens, right? Nothing happens. Very sorry for that, but then nothing happens. The velocity stays, the acceleration stays the same. Why? Because like I said in the beginning, when we describe vertical projectile, the object itself has to be influenced by gravity. Gravity itself is 9.8, right? And for this one, it is for when up is positive, right? Yes. So for all of these ones that I just said, just for recap purposes, all of these graphs here are for up is positive, right? Yeah, up is positive. Now if down is negative, obviously it's written here, it's the same. But then if down is positive, there will be vice versa, right? Vice versa. Alright. Alright, good. So now I want us to draw the different types of vertical projectile graphs for different scenarios right now. Right? Then after doing this, we are going to draw the special projectile paths after this, right? Good. So let's begin. Say there's a person. These are exam type questions, by the way. Say there's a person here standing up here. Now this person drops the ball from the height of the building and then it hits the ground. And then you're asked to draw the vertical projectile graph, right? They want you to draw the change in y and the v and the acceleration graph. So you have to draw the change in y and the velocity graph, the displacement graph, and the acceleration graph. Those are the three types of graphs you have to draw for the scenario. And you have to take what? Up as positive. Good. So in this case, what are we gonna do? Now that's a very interesting question. Okay. So here's what we're gonna do. Let's start with the change in y graph. The change in y graph, it's the most simplest graph because it basically just describes the motion itself. Let me just write change in t, change in y. Here's why. This person dropped the ball, right? So if he drops the ball, the velocity is 0. Those are the terms in projectile. Dropped, projected, it means it's given a velocity of which you'll be told or you will have to find. Now in this case, for instance, it will start at 0 and it describes the same motion that I have drawn. Like I said, it's easy, the change in y, the position time graph. So this is how you're gonna draw the graph, right? Not in dots, by the way. Let me try and make it accurate. You're not gonna draw it in dots, right? It's gonna be like this. This is your graph because it's describing the building or the position or the direction or the distance that the ball itself traveled going down. Right? Good. Now let's draw the v velocity graph, right? T, this is the versus t. Now let's come here. Now we're drawing the v, the velocity time graph. Now for the velocity time graph, it's going to be slightly different, right? Because now, let me write here with the, let me find this color here and say up is positive. Right. So yeah. Okay. So let's come here. The velocity graph. Now for the velocity graph, how are we going to describe it? Now for up is positive, here's how. So this is changing y, changing t, sorry, and we have the velocity. Now for this one, it's going to be quite interesting because you have to actually know the initial velocity, like I said. But then in this case, I said v initial is 0 because it is dropped, right? So it's gonna start here, and it's gonna be what? A straight line, right? Please don't put this. Right, so that's basically how you're gonna draw the v versus time graph. Good. Now here's a tip for those who don't understand yet. Even if this ball had a velocity, right? Remember what you are looking for or what you are drawing when you're using the graph. The graph itself, I said, it's the velocity time graph. So you're looking to explain the velocity of that ball with the graph. So for the position graph, it starts at the top with the person holding it. So the distance that this ball has traveled so far is what? Is 0, right? So this means that the object itself has not moved too much, right? So it's gonna start at 0, describing the motion. If the velocity was not 0, by the way, I'm just saying don't cram on say or say that okay. So since if the velocity is 0, the initial velocity is 0, the position time graph it will start at 0. No, no, no. It depends on the scenario. But then the position time graph it's just gonna begin at 0 because that's where the ball started to move as it goes down, right? So yeah. So let's do the last graph here, so that we can do the other scenarios here. Good. Now we have the sun, of which is the acceleration. Now acceleration, I'm just gonna draw it for this time only because it's basically if they ask it in the exam, they will be tricking many students because usually they used to drawing the position and the velocity graph. Now for the acceleration, it's constant. It's the same because it's moving under the influence of gravity. So this is the acceleration. There's nothing much to it. It's boring, right? So let's look at it at a different standpoint, right? Right. All right. Now here's another scenario. Now this person projected a ball. Now the V initial is not 0. Now this person projected the ball. I'm going to use a different color. He projected it and now it's going down. Now since the person projected the ball, he did not drop it or do anything that would say the V initial is 0. They didn't even tell us. The key point is the ball is projected, right? So if it's projected, we have to find and explain its displacement, its velocity. Acceleration, I won't do it, but then I'll do it for this last time. But it's constant, it stays the same, it doesn't change regardless of the weather. Gravity, it's always here. If it wasn't, we would be going up instead of down when we're jumping. Right, so now we're going to draw the displacement time graph. Right, displacement time graph. Here's the displacement time graph, and we should be doing it like this. Now remember I said this ball is projected. My diagram is not drawn perfectly because it goes up and then it goes down. Now if it goes up, it will start at a certain velocity. Now let's say the distance, this is the change in y, by the way, this is not the velocity. Let's focus on the distance it travels, right? So the person is holding the ball in his hand or her hand. So at that point, that's 0. So this means we're going to start here, and then he or she projects it up, so it's going to go up, and then it's going to come down, and then go down, right? So this is how you draw this one. Then you're done. You just explained it. The person is holding the ball, projects it up, it's going down. Then you're done. Now, in most cases, they may give you points like um, they want the velocity or the time at which the ball touches the Cartesian plane. They may give it to you, like of which they want this point here. In order to find that point, you just have to come to your graph, know that okay, here the change in y is 0, and then here it's at its max. This is the maximum height, so the VF here is what is 0, and then you're gonna correlate from that if you want to find your time. Alright, good. We're gonna do more problems, or there's going to be a playlist after this video. Right, now after drawing this, let's go to the velocity time graph, which is the V. So the V versus time, right? Good. Now for the V versus time, this is where we explain the velocity. Now remember, we can't say this ball, it's dropped, it has a velocity, a V initial of 0. You can't say that because it is projected. Now, if it's projected, here's what we're going to do. It's projected. It starts here. And please don't make this mistake of using a parabola when describing the motion, the velocity graph. Please don't use that one. It's a common mistake I usually see when I mark the question papers. Please don't do that. So, yes. So you're just gonna draw a straight line graph for this one. So this is going to be a straight line graph, and done. Now, like I explained in the previous page, I said this. The reason why we're drawing it like this: when you throw a ball up, its velocity decreases. So as its velocity is decreasing, it's gonna reach a point in which it stops in the air and then comes down, and its velocity what increases. So when you do the velocity time graph, remember that okay, if the person projected it, it has a certain velocity. The velocity as it goes, the ball as it goes up, its velocity will go down, and the ball as it goes down, the velocity will go up. And in simple terms, I'm going to explain this right after this the acceleration graph. But the acceleration graph, like I said, it doesn't change. And in this scenario, up is positive, right? Let's write it here. Up is positive. Up is positive. So if it's going up, and it is what? It is positive. Right, good. Now, let me explain what I was saying when I said as the ball goes up. Now, here's the distance of an object. Let me draw it here because we're going to need space. Right, now here's the motion, right, of a ball. Now this ball has traveled this distance, this motion, right? This is the displacement of the ball. Now we have to find out its velocities. I want to teach you guys of why you draw it like a straight line. So the velocity at this point, it is what? It is 0. Yes, depending, because the person is holding the ball, and now the person throws the ball up. Now as it goes up, the velocity, let's draw a little bars here, and I think it should be good. Now as it's going up, velocity is going down, velocity is going down, velocity is going down, right? Then v then v is equals to 0 at this point. Now as it goes down, the velocity goes up, velocity goes up, velocity goes up, velocity goes up. That is what you have to know. And in this case, how will you draw this graph? You're just gonna draw it like this. You see if I can try and clear this out. You're gonna draw it like this. It starts at 0, so it starts at 0. It has to have a point at which it has to have a what? It has to have a what? A point at which it stops, right? So let me remove this. The v initial will not be 0. Why? Because the person has to throw it up, right? So remember that one. That's the mistake. And it's gonna be like this. Yes. Now that reaches the point of which the common types of graphs you may have to know and understand, right? So the last one, it's the bouncing and the one that is thrown on top of a building, right? I'm gonna draw it here. I'm not gonna draw it too far. I'm gonna draw it right here. Good. Now here's how we're gonna do it. Now for the one of the bouncing, right? Let's see if I can remove this one. And good, I think this is much better. Yeah. Alright, so here's the scenario. This person is here, and this person is throwing a ball on top of this. Now you're required to draw the displacement graph and the velocity graph. Now the ball is gonna go up and 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 up, and it's gonna reach to the top of the building. Now here's what we're gonna do, right? And it's gonna go is so in this case, how are you gonna describe it? Now, like I said, the change in y, the position describes the motion at which the ball it moved, right? So now remember that this person threw it from immediately if the person is holding the ball did not move any distance, so it's just gonna begin at 0. So we're gonna begin at 0 and go up until this point here, because I don't know what's the height. The height will be given it in this case. Now what is the velocity? This is the t, right? Right. The change in y versus the t. Now what is the v? Now the v versus the t, in this case, it's going to be what? It's going to be like this. And this is the change in t, and then this is going to be the v. Right? I think I'm going to need to move that, but it's fine. So remember that as the ball is being thrown up, the velocity goes down. So we're going to be going down, and the person projects it, so it's going to be going down up until a certain velocity at which it stops, right? Or point, right? Good. So this is how you're gonna draw the v and time and the change in y and the, and the acceleration. In this case, it's still the same. It's not affected by anything. Nor is it affected by the distance or anything else by that, right? Good. Now let's say the ball now it bounces. Bouncing scenario, it's always the one that tricks a lot of people. But then we're gonna debunk it today. We're gonna try to make it easy for everyone to understand. Right, now let's begin. Now the bouncing one, let's say this person is here standing on top of the building, and now this person throws the ball up and it goes up, and now let's say there's a balcony here of someone, it's a hotel. Now it goes down. Now the ball will bounce from this point and go up, and now it's gonna go down, hitting what? The ground, right? Good. Now how are you going to describe its motion? Right? Like I said, if you look at this, the change in y versus the time, how are you going to draw it? Like I said, you're just going to draw the graph. Look at what you see here. Look at the lines. This is the 0. This means you're going to start it at 0, go up, and then go down, go up again, and then you're done. Let me show. Let me show you guys. So you're going to start at 0, it's going up, and it's going to go down. And you're going to show this point. Yes, you have to. This is the point of which it hits the balcony. And then it goes up again and goes down. Now, this is how you explain it or you show it, right? Good. Now, let's come here to the velocity time graph, right? Now, the velocity time graph, how are we going to describe it? Good. It starts at this point. This person has projected this. He's projected the ball up, of which it's gonna go on. If the ball goes up, the velocity does what? It goes down. Now, velocity goes down and goes down up until it reaches its v at its maximum height, which is represented here, and then it goes down again up until it hits the balcony and stops for some milliseconds, and then it goes up again. And voila, then you're done. This is how you just describe this case of the bouncing. The bouncing, this is how you're going to show it. And for more purposes or practice purposes, I am going to be doing more and more activities under the vertical projectile in order for those who want to practice and understand it, especially the graphs and how we do it. So this is how, or this is the introduction to vertical projectile and how it is. Now, the bouncing, it may be different, and sometimes yes, it's gonna be weird, but we will be doing those activities right after these videos. This is just the introduction video for vertical projectiles for those who don't understand it.